All right. Good afternoon, everybody. That was a tough act to follow, but I do get to say, please stay around till the end of the conference. We have great raffle prizes. We have beer and wine coming up later, so I hope you stick around for it. All right, so I wanted to discuss some current trends in RISC-V in the automotive industry. How many functional safety engineers are in the room? Anybody functional safety engineer? Good. So I wanted to talk a little bit about ISO 26262 and functional safety, introduce you to Andy's functional safety solutions, and then also dovetail that into various security concerns. Okay. So some of the trends in the automotive industry are, we now have all the cars are drive-by-wire, brake-by-wire, steer-by-wire. There's a lot of V2X communications, all kinds of wireless communications, both vehicle to vehicle, communicating to your devices. We have vehicle electrification ramping up, autonomous driving, and eventually getting to software-defined vehicles. Okay, so this is changing, it's revolutionizing the electronics architecture inside of vehicles. They're shifting from a lot of disparate remote ECUs, moving into domain and zonal controllers, so an ADAS domain, the infotainment domain. And eventually, we see this going to more centralized vehicle compute architectures. Okay? Along with this is an explosion of the code base that's happening in vehicles. So roughly today, 200 to 300 million lines of code, with autonomous driving, maybe going over 1 billion lines of code per vehicle. Okay. Oops. So this is actually a wonderful fit for RISC-V and what RISC-V brings to the table. We have anything from small ECUs to domain controllers to centralized vehicle processors that can centralize on a single architecture. And by doing that, can be optimized for their specific application, but still retain a good amount of software optimization and use across vehicles and code bases. So this introduces the question of functional safety. Why do we need functional safety? Anybody remember the Toyota unintended acceleration issue? This ended up claiming many lives, probably cost Toyota north of $5 billion. Okay. Takata airbags were inadvertently deploying unexplainably. Takata went bankrupt over this. And just the other day, it was announced that there's still over 6 million vehicles on the road with these defective airbags. Okay, so these things live on for a really long time. Last example I'll give is Tesla. This one's kind of autopilot. How do we bring safety to these functionalities? So this is the need for functional safety. All right. ISO 26262 defines functional safety as the absence of unacceptable risk due to hazards caused by malfunctional behavior in the electrical system of the car, the electronics. Okay? It categorizes things into ASIL, Automotive Security Integrity Level. And in this chart, you can see a number of different ASIL classifications for various subsystems. An example would be the airbag, specified as ASIL D, the highest classification for safety. Right? Now, one thing to keep in mind is these are specified from a vehicle level downwards. Right? So it's for the entire airbag system of the car, not an IP in it, not an SoC in it, the entire airbag system. And when we look at ASIL, there's ASIL's ratings from A through D. D is reserved for unacceptable levels of risk, which are a combination of how severe is the damage to humans and what is the probability or exposure of occurrence, down to ASIL A, which would be kind of your less severe safety critical cases. And in ISO 26262, failures are categorized in two categories. Category 1 are systematic failures. These are completely preventable. They're considered to be a failure in the design process or the manufacturing of the component. The second failure is random failures. These are not preventable. These are considered to be things like soft errors, a bit flipping in a memory. Okay. To address systematic failures, ISO specifies a detailed V-model development cycle. The resolution to systematic failures are a safety culture in a company, safety processes and safety lifecycle management. The solution for soft errors are mitigation techniques. How do you detect and handle a soft error so that you fail safely? All right. Both systematic and random failures need to be addressed. And there are external organizations like TÜV, like Exida, that actually go and certify components, IPs, automotive manufacturers, that they are indeed compliant to a specific level of ASIL. And this is really prevention for both increasing safety and, maybe lowering your litigation risks later on in time. Okay, so how does Andes bring automotive safety to market? Andes began in 2020, where we did the first step of getting our design processes and our design flows ASIL qualified and certified by TÜV. Okay. In 2022, and actually just a couple of months ago, we released 2 ASIL qualified cores. These are certified to ASIL B levels. We've gone and got the complete certificates to those to certify that they're fully compliant. Right? And coming up in the future, we're also going up the chain into our 45 series. We're going to release a lower end 23 series and eventually our 6 series. So we will have everything covered from kind of ECU level controllers through domain and zonal controllers all the way up to high performance vehicle central compute. Okay. And we've already had one customer, actually 2 customers, take our safety deliverables and go and get their own product safety certified. That's the benefit of using safety certified IP, so that when a customer goes and puts this IP in their SoC, they have all the supporting documentation to go to the certifying authorities and get that certified. All right. I'm not going to spend a lot of time on this. You'll find this in most CPUs. But there are a set of features that help mitigate the hardware risks, things like ECC and non-maskable interrupts. There's additional safety mechanisms, how we protect buses. In the upcoming cores where we're getting ASIL D certified, we do dual lockstep configuration. So 2 cores running side by side, comparing the results. Also, we deliver a full safety package with our safety certified cores. So our customers get a safety manual, they get the FMEA reports, the FMEDA reports, and the development interface outline, right? So as an element out of context in safety, our customers need to know what assumptions we made in our safety ratings so they could incorporate those in their design. All right, the other thing that needs to be considered, we've talked about hardware so far. There's also a software component to safety. So software is actually considered to be systematic only. Software is either buggy or it's clean. In fact, in the Toyota case, after many, many litigations, one of the arguments against Toyota was that the software violated MISRA-C all over the place, right? It introduced doubt into, did they have a safety culture? Did they follow protocols? Okay? So the way we address the software component is we bring together a robust and lively ecosystem of our software partners. We heard from some of them today. They do certified compilers, certified tools, certified RTOSs, AutoSAR systems. Okay? So the combination of certified Andes cores with certified software stacks really enable our customers to get to market quickly and get their products certified for automotive use. And we've had a lot of customer success. So you'll find us in display, automotive display and touch sensors, camera sensors, in-cabin radar, a number of auto MCUs, in-vehicle storage systems, and actually thus far, more than 10 customers have licensed the SE cores. Over 5 of them are currently in mass production, and 2 have been certified their end products, with more on the way. Okay. So the other part of things to address in automotive is security. The automobile has become just one large attack surface. Right? You've got USB ports, you've got Bluetooth, you've got Wi-Fi, you've got the V2X communications, you've got wireless tire pressure monitoring systems, not to mention the CAN buses, the key fobs, and everything else, the IVI system. Okay? So regulations have kind of been a little bit behind on this side. If you go back to the ISO 26262 on functional safety, that goes back to, I think, 2011 for one revision. The last one was 2018. On the security side, the earliest one that there was kind of an Avita specification back from 2010. This was sponsored out of Europe. Recently, in 2020 and 2021, UN resolutions R155 and R156, specifically dealing with vehicle security management systems, as well as how you do secure updates to the vehicles. And we're starting to hear more about ISO 21434, which parallels 26262 in the V model, except applying it to safety. Okay? And security is becoming important across all segments, not just automotive. Right? It's important in financial transactions, in IoT, in security. And there are a number of regulations that are continuing to roll out in organizations that are trying to make standards around security. GDPR, the FTC, California Consumer Protection, NIST, right? And I'm sure there's plenty more besides these. So how does Andes address security with its RISC-V processors? We've put together an Andes Sentry, what we call a collaborated framework. And there's really 4 components to this. The first component is the RISC-V CPU IP. That includes hardware isolation and protection mechanisms that are needed to create secure zones of processing, right? So things like the physical memory protection, the enhanced memory protection, I/O peripheral protection. Okay. The second aspect of this is we take it and we integrate it into a secure platform. So this is a deliverable we have. It has a number of the peripherals you would want. It has on the lower right there a secure island for security processing purposes, and a bunch of your typical bus interconnect structures. The third aspect is we have pre-integrated solutions with a number of our security partners that would fill that red box on the lower right, to include things such as hardware root of trust and different cryptography algorithms. Okay? And finally, we provide a software stack for secure monitor. Right? We own the Opti project. The project's owned by RISE, but we are doing the ports and contributing that back to the open source community. We've also done an MCU trusted execution environment that we deliver with our MCU cores. Right? So when we look at it from a complete secure stack, at the baseline we start with the hardware, which is the RISC-V cores with the secure isolation and hardware protection features. And then around that we wrap our secure pre-integrated subsystem. We deliver on top of that the first stage bootloader, secure boot, the necessary boot code, and then the secure monitor through either Opti or our MCU trusted execution environment. And so we offer that for both Linux, which you could actually, I think we're demonstrating our Keylib board running Linux out there today, and also on an MCU solution. So just to summarize, RISC-V is actually really well suited for automotive applications. We scale from MCU level performance, relevant for many of the ECUs in a vehicle, all the way up to high performance, multi-core out of order, which would be more applicable to kind of the central compute, and everything in between for domain and zonal controllers. Right? The customization available in RISC-V and the extended ISA allows our customers to optimize the processors to the specific domain needs, whether that's an image processing need, whether it's a radar signal processing need, or something else. Right? So that could be an optimal processor, but still leverage the entire software ecosystem and software stack built around RISC-V for automotive safety and security. Safety is a hard requirement, and it is throughout the entire supply chain. Right? If you think about this airbag safety as an example, Toyota specifies a requirement like the airbag shall not inadvertently deploy when you're driving. That's the safety requirement. Nobody goes down and says, my board shall have this level of safety, my SoC has this other level of safety, and the IP underneath it has something else. The supply chain has to provide that information down from the base levels all the way up through the supply chain so that the car manufacturer at the end of the day could build its safety case and protect itself from litigation. Okay? And in that, having fully compliant IP is essential. It eases that proof burden all the way up the supply chain. And the final point, I think, is, security has just become essential across not just automotive, but all application domains, right? We've worked hard to create this Andy Sentry framework and really try to bring together reference points with pre-integrated security solutions from partners to really help meet the stringent security requirements and speed our customers' time to market. Okay. So thank you.